All right, let's talk a bit about routing. So let's start brief review IP addresses. So I've got an IP address here, 192.168.25.25/24. What that means is that the network address for that is 192.168.25.0. And the network address is important. It's especially important for routing because that's how devices know if they can talk to each other. If I see another device with the same network address as me, I know that that device is on my network, which means I don't have to go to a router to talk to it. I can talk to it directly through my network. So I can send a message out directly on my network, and we'll talk in the data link layer a little bit more about how that happens. But I could talk directly within my local network with the other device. So if my computer here, 192.168.25.25, wants to talk to 192.168.25.27, I can talk directly. I don't have to go through a router. I don't have to go across any other networks. I'm just going to talk to 192.168.25.27. However, if I want to communicate with a device that is not on my network, we need to do something else. And that something else is finding another way to get outside of my local network and move my packets, my traffic, to another network. And the devices that do that are called routers. Routers move traffic from one network to another. So if me on 192.168.25.0 wants to send something to 192.168.27.0, that's on a different network. And to do that, to be able to communicate between different networks, I need a router. And at the bottom here, I've got a picture of what a router looks like. It's got a bunch of ports on the back. This is what an enterprise grade router looks like. Now, you probably have a router in your home, a baby router of some kind, and we'll talk about those in just a minute, but this is what an enterprise grade router would look like. And another thing that routers do, besides just moving stuff from one network to another, is that they try to find the best way to get to the destination network. So if I'm sending something from me to Amazon, each router along the path is going to forward that message to the next network along the path, and they're going to try to send it to the best network, the fastest network, the shortest path for me to get from my computer to Amazon. And then on the way back, the same thing's going to happen again. So here, if you run on a Windows computer in the command prompt, if you run the command netstat-r, then you can see your own routing table, and you'll probably see an IPv6 routing table, and you'll probably see some other little bits of information in there. But the meat of it that we're talking about right now is this IPv4 routing table. And there's a whole bunch of things on there. The most important things to note are the network destination, meaning your routing table contains what network you're trying to communicate with. It contains a subnet mask so that it knows what the network ID, the network address is. And then it contains a gateway. And the gateway is, how do I get there? Where do I send traffic if I want to get out of my local network? So at the top on this computer, 0.0.0.0 means any network. Any network that's not otherwise listed here is going to send traffic to through 137.48.187.254. And the interface, my IP address in this case, is 137.48.184.155. So it says, how do I get there? What device am I sending it to next? What's the next hop, the next step along the path? And then what interface is it that I'm connected to? What interface do I have? So if I had a wireless and a desktop, or if I had 3 wired network connections, it would have this information for all of them, and I would be able to determine which is the best interface to send this traffic from. So default routing is the easiest form of routing. Really, I mean, I'd call it baby routing, because all it's really doing is saying, if I don't know what network this is, if it's not on my local network, I'm going to send it to X device. And it doesn't matter what other network it's for, I'm sending it to X device. And that's what your computer does. if it's not on your local network, all your computer does is it sends that traffic to the router. The same with your router, if you're at your house, most likely, probably has one single route. All it says is, if it's not on my local network, I'm sending it up the chain to the ISP, and the ISP can handle it from there. And within the ISP, you've probably got routers all over the place, and if you wanted to send something to, say, if I'm on Cox and I want to send something to another site that's within the Cox network, then that would get routed within their network using more advanced routing. But to get out of my local network, all I'm going to do is send it to my router. And then my router, all it's going to do is look at it and say, hey, I don't know where this network is. Send it to the ISP. So your computer does this, your router at home does this. And it looks a little bit like this. So, for example, these 3 different homes have their own routers. They have their own IP addresses. So the 68.47.125.8 and .9 and .10. And if those devices want to talk outside of the 68.47.125 network, for example, then they're just going to send that to the Cox router. And that's going to be configured as their next hop router or their default gateway. So it doesn't matter where you're sending it. If you're sending it to Amazon, if you're sending it to Google, if you're sending it to something else on a different part of the Cox network, we're just going to send it to that router and let the router worry about it. Now, if we wanted to do a little bit more advanced routing, what I call real routing, you're going to do something a little bit more. And what you're going to do is have a routing table. And the routing table is, well, it's a lot like this here. But it has a lot more information. So this routing table, while it has a lot of stuff in it, it doesn't have a whole lot of different networks. In fact, it really only has the 192.168 network and the 137.48.184 network. And nothing else, no other networks are contained in there. However, if you were a real router, say within Cox's network, you had one of their routers, then you would... And again, I'm not talking about the router that you have in your house. I'm talking about the routers that Cox has inside their network that they're working with. Those are going to keep track of a whole bunch of networks. And it's going to keep track of all the networks that they know of. And it's going to figure out the best way to get to each network. And there might be ties. There might be 2 ways that are equally good at getting somewhere. But the routing table is just going to keep track of how to get from network A to network L, or network A to network Z. And all of those networks, all of those different networks are stored in that routing table. So this is what it might look like inside of Cox's network after I send something to the router. You see we have 68.47.129, 68.47.128, 68.47.127 up at the top, 68.47.126 on the left. All of those different networks, those are different networks. And so to be able to communicate between those networks, each of those routers is going to keep track of how to get there. So the router in the bottom left knows that if it wants to communicate with the router in the top right on either the 68.47.128 network or the 68.47.127 network, it knows how to get there. And it knows that if it wants to get to the 68.47.127 network, it's going to send that up to the router directly above it. And then that router is directly connected to that 127 network. If I want to send it to the 128 network, then I'm going to send it to the right. And so the router in the routing table keeps track of the best path to get between those things. So we can see the routing table here. This is what a routing table looks like inside of a real router. And it's got the network address, the subnet mask, and it's got information about where it is. In this case, these are 4 networks that are directly connected through 4 different interfaces: fast Ethernet 00, 01, 02, and a serial port. Each of those networks is directly connected to this router. And so it's routing information between those 4 networks, but it doesn't know of anything else. In this case, we've got a bit more of an advanced network and a few more different devices going on. And you see these routing tables. Each device has a routing table that contains information about all of the networks. So on the left, we see the routing table that says 172.16.10 is on F00, that network connection, that interface. And you see on the far right of that routing table, there's a metric, and that metric is 0, meaning it's directly connected. And you see if it wants to get to 172.16.20.0, it goes through the same interface, but the metric is 1 because it's no longer directly connected. We have to go through another router to get there. The same with all of the other networks that are connected there. And that's the basics of how routing works. We'll talk in another video more about how this routing table is created and how the routing table might be used and what kind of metrics, what we're talking about when we talk about metrics. But this is what routing looks like inside of a real router. And remember, your router at home it barely counts as a router because all it's doing is forwarding all of your traffic out to the ISP. And that's it on that.